All right, welcome to SUSECON. Welcome to the sponsor session. Hey, I wish we could throw out like virtual swag into the audience, and we've got these cool SUSE plushies here, even with the HPE logo on them. Totally cool. Maybe next year I'll be able to see you guys in person and we'll be able to hang out and I'll get you some of this stuff, get you some of this conference swag. I'm going to make myself a lot smaller. And thank you again for attending the sponsor session. I know a lot of people hesitate because it's usually high end hyperbole, being the sponsor session, a lot of marketing, a lot of sales. I'm not a marketing person. I'm not a salesperson. I couldn't sell you $1 for 99 cents. So who am I? My name is Craig Lamparter. And for the past 30 years, I've worked with Hewlett-Packard Enterprise. I'm a Linux system software engineer, and I work in our Linux Enablement laboratory, where ultimately our goal is to make Linux-on-ProLiant the best combination in the industry. As I'm sure you can tell from my U.S. English accent, I am in fact from the United States of America. You might further assume I'm from Houston, Texas. In fact, that's our new building there. It might be a rendering. There's people messing around in the in the yard there. Actually, I'm not. I'm not from Houston, even though that is our headquarters. I'm from California, but not the Bay Area, not Silicon Valley. I'm from the other side of California, and this is me doing stuff in what is ostensibly my backyard. But hey, we didn't come here to talk about me or geography for that matter. We're here to talk about SLES enablement on HPE ProLiant servers. This is a quick agenda. I'm a KDE desktop user, Linux desktop user, so you're going to see KDE icons throughout a lot of my presentations. I guess because they're at least copyleft. I know we can use them. All right. We're going to talk about how we work with SUSE. Every day we're working with SUSE. And we're going to talk about hardware partners. There's a lot of little bits and pieces that go into HPE servers, and there's a lot to manage there, from a driver and even firmware perspective, and how we work with SUSE to manage HPE hardware. We're also going to talk about the service pack for ProLiant, which is a collection of drivers, agent software, and firmware. Okay, and to help make Linux and SLES run best on ProLiant. And then we're going to talk about HPE Linux value add software. And then finally, the one URL that you can take away from this whole presentation, that's downloads.linux.hpe.com. And that's where we've got zypper and yast repositories for all of the software and technologies that we're talking about here today. All right, so the SUSE partnership with HPE. Let me see if I can get out of my own way here. I'll make myself even smaller. So we support SUSE Linux Enterprise Server. We don't specifically support OpenSUSE variants. So those are supported by the community. And then this is in no way in any order of technical merit. A tumbleweed is arguably more advanced than SLES. So there's no order, there's no judgment here. It's just that the SUSE Linux Enterprise Server is really the commercial variant of SUSE that we're interested in here. So we have technical reference forums with SUSE. We have employees on site at Nuremberg. In fact, you might even see me there at some days. We've got SUSE people in Houston, helping us out. Shared engineering resources. We share product roadmaps, all under NDA. So, when there's new hardware that comes out, we guarantee it works on SLES on day one, and vice versa. When there's a new version of SLES, we know it's going to run on HPE servers. So we do work with SUSE really closely, particularly on SLES. Now, for the community stuff, for community engagement, we engage with the community. We do some sanity testing. We don't do any certification for these, and there's no specific support for OpenSUSE variants, right? So we're really talking about SLES when we're talking about supporting SUSE on HPE. Now, hardware partners. Obviously, there's a lot of hardware that goes into an HPE server. I don't know where to hide myself. I'll hide right here. Kind of out of the way. So CPU, network cards, storage, host bus adapters, management ASICs. There's a lot of hardware that goes into an HPE server. So AMD and Intel stuff, that's kind of obvious. You do have to manage that to some extent. There is microcode that's signed by these partners that we load into CPUs, at boot time, and we have to be aware of that. The network and fiber stuff is kind of where it gets a little more interesting. I kind of want to emphasize what the drivers are for these. That's why you'll see the driver names here next to each one of these. And the reason a lot of the driver names don't match is because there's been a lot of not turmoil, but opportunity in the industry where we've seen some acquisitions and spin-offs in the NIC space. So, I had to actually write it down because I couldn't remember, the history of this. So the history is that Broadcom tried and failed to acquire Emulex. Stay with me. Avago acquired Emulex, and then Avago acquired Broadcom, and then Avago changed their name to Broadcom. So that's why there's a lot of differences, comparing driver names to actual names of the actual partners. And later after that, Mellanox was acquired by NVIDIA, so we work with NVIDIA now. Now, all of these companies are fantastic to work with. They provide great drivers for this hardware. We work with them to make sure that their drivers are working with the chipsets that are inside HPE servers, and we work with SUSE to make sure those drivers get loaded on day one. So that explains why some of these driver names seem a little odd. Doesn't exactly match the company. The one that's been consistent is the Intel drivers. If it starts with an I, it's probably an Intel driver. So moving on to storage, we work with Microchip and with our Smart Array host bus adapter. The latest driver for that is going to be Smart PQI. So the HPE SA driver, that's old news now. I don't know if you've been around long enough. We used to have the Kisses driver way back when, but we've been working with the Smart Array folks for a long time in HPE ProLiant servers. And also Broadcom. We're working more and more with these folks. You'll be looking for the Mega Ray driver for them. And then disk drives, while they don't have drivers themselves, you do have to maintain the firmware in a disk drive. They kind of have their own little operating system to manage. So don't forget disk drives. And then, of course, we've got management ASICs inside of HPE servers, like our management processor, HP ILO, there's a driver for that. Their Watchdog timer, the TPM for application certificates. And, that's just software we need to manage from a driver perspective. So these are our hardware partners that we work with SUSE kind of in a three-way relationship to make sure HPE hardware works best with SUSE. Don't forget disk drives. This is, I think I said that in the previous slide, but don't forget disk drives. This is just a list of disks partners that we have: Seagate, Samsung, Western Digital. This is just me doing a firmware dump of all of our firmware, or at least that's not even all of it. Wouldn't even fit on the slide. Let me scooch myself out of the way here. But remember, disks need firmware updates now and then. That's the takeaway from this one. All right, so let's talk about the service pack for ProLiant. This is a collection of drivers, firmware, and agent software. Remember I said I'd say those three things over and over. And those are that's stuff that you need to keep up to date for one, and two, you can leverage them really to get the most out of your investment. All right, so this SPP, the Service Pack for ProLiant, works with ProLiant branded hardware. It's not going to work with other servers from HPE that aren't ProLiant branded, and it's specifically for SUSE Linux Enterprise Server. We actually have drivers, KMP files, kernel module packages for SUSE. If you want to get a driver from HPE, we have firmware that we'll talk about here, and agent software that you can run to help manage your hardware. So we deliver this either in an ISO image or in individual component downloads. Remember I mentioned the one URL to take away here was downloads.linux.hpe.com. That's our yum or zypper and yast repositories for all of our RPM-based content. And this is all consumed by Smart Update Manager. If you're familiar with HPE SUM System Update Manager, this is kind of you can actually boot this offline. You can actually boot this disk, and you can update your system in an offline mode. And updates, that'll include drivers and firmware. And it's kind of a solution-oriented way to do this. But we also have a DevOps approach to this, where we've got everything loaded into online repositories, which is really what the Linux community has come to expect. I mean, you got to understand that the days of downloading an ISO image are kind of over. It's kind of last century. Totally understand that. And even the days of downloading content using a web browser, that's over. We expect everything to be in an online software repository now, and that's where downloads.linux.hpe.com comes in, so you can get all of this content from the Service Pack for ProLiant there as well, not just the ISO image. I really don't know where to hide myself. I'll hide myself up in this on this corner on this slide. So, okay, so I said we're going to talk about drivers, firmware, and agent software over and over. So let's talk about drivers a little bit. A lot of people ask and say, "Hey, Craig, should we use the in-distro driver for this Intel NIC, or should we use the driver from HPE, in your online repositories, your kernel module package?" And the answer is like it's really up to you. Sometimes there might be a reason to use one or the other. It depends on your installation. But we really are trying to make sure everything's in distro to give you the best possible experience. So the answer to that question is really you can use either one you want. The drivers provided from HPE or the drivers provided by SUSE. We work with SUSE to certify HPE servers with the drivers that are built in distro. So it'll definitely work. If you just boot SUSE stock all by itself. Every now and then there might be a KISO, we call it KISO, it's a bootable driver kit, I think that's what SUSE calls it now, and that's kind of a driver disk that you can get from SUSE, and we'll work with them if there's any drivers that we have to wedge in after the fact, or maybe for older versions of SUSE. Of course, you get everything from HPE is cryptographically signed. You want to import our keys, if you're using our drivers or our RPM packages more specifically. And this is just kind of an anatomy of a driver. Make sure I'm not occluding you guys. This is what a driver looks like. So if you just run mod info on let's say this is a Broadcom driver, bnx2.ko file, you can get more information about it. Sometimes it's just hard to say, well, what hardware is in my system? A lot of times just by looking at the drivers that loaded, you can see what hardware is actually there. Your hardware's in the depmod database and ultimately pulls in the right driver. So you do ls mod and you can see, hey, there's a bnx2 driver there. You look in this directory, this is where they're actually installed. You can do mod info on it to get the version, see which version of the driver you're running. Actually, I have to take that back now because with the newer Linux kernel, the 5 series kernels, the version isn't in mod info for the kernels. I honestly don't know how to work around that. So, we obviously post a driver version in our RPM packages. So I don't know, maybe we can get together as a community and try and figure out, what's the best way to do kernel driver versioning now that we don't actually call it out in the mod info pound defines in kernel objects these days. But anyways, there's lots of good info. If you just run the mod info command, you can get more info about the driver. And this is an example, this is a QLogic driver, even though it has a Broadcom designation in the driver name. And hey, I just had to call out Michael Chan here. Hey man, you're really brave putting your email address. This looks like your actual email address inside of a driver. So hey, thank you, Michael. So it's just a good example of how you can approach the community. Maybe you just got a quick question about the driver. Well, there's the driver author right there. You can email them. The important thing here to take away from the driver's slide here is that the SUSE does maintain a stable kernel ABI application binary interface. So when you do load a driver in, the original kernel, the GA kernel, and then you upgrade to an errata kernel later, it's going to continue to work. The driver that you installed in the old version of SLES is going to continue to work. It's going to be carried forward into the errata kernels down the road as you update them. So what's cool about SUSE when it comes to drivers, they have this idea called KMP. It's called Kernel Module Package. And this is how we supply drivers to SUSE. This is the anatomy of what a driver, KMP driver RPM looks like. It's just a handful of files in it. There's usually a config file and the actual driver itself. This would be smart PQI. It's always going to land the driver into lib modules, kernel version updates. So you know where to find the driver there. If it's not working out, you could just delete it if you wanted to. And then, like I said, if what happens when you install an errata kernel, it takes all of the drivers out of the updates directory and then puts them in the weak updates directory into the new kernel errata tree. And this happens when you install the SUSE kernel. And that's assuming that all of the symbols still exist in the kernel and that you can still, the linker can still load the driver in with the monolithic kernel. And it'll move that forward. And it does because SUSE maintains a static binary kernel interface, which we appreciate. That way we don't have to release a new driver for every single errata RPM. So that's kernel module packages. I know a lot of people aren't familiar with that, but it's kind of a cool SLES thing that we leverage here at HPE. Like I said before, we really are pushing for all drivers to be in distribution. It's really the best experience, right? You just want to put in a piece of SUSE media into your HPE server, boot it, installs, all the drivers are updated, everything's the latest and greatest, and there's just it's a flawless initial experience, and this is what we really expect, right? And that's what we work with SUSE closely to make sure that we certify with in-distro drivers. And really, there's clear support expectation too. If all of your software comes from one place, all of your hardware comes from another place. And we do sell support, for everything. If you want to buy an HPE servers, well, you can get SLES from us. We'll support SLES. Tier 1, Tier and 2 will be covered by HPE, and then of course we can escalate issues to SUSE, or you can just buy stuff directly from SUSE and get your support that way. There's a lot of options there. So when we're talking about drivers and why we have drivers or driver disks, we talked about the bootable. I wish I could remember the name, but we call it a KISO internal bootable driver kit. It's like this driver disk on steroids, and we'll load drivers, boot essential drivers into that if we need to work on older versions of SLES, or maybe I'm showing this release cadence here. It always seems like we release new hardware like a few days after the deadline, the cutoff to get stuff into SUSE. So every now and then there might be this need to have this driver disk, bootable driver kit. And this is just an example, this is how we develop new servers. This is what our timeline usually looks like. And then we're working closely with SUSE, say, hey, we make sure to get with the latest version of SLES, we need to work with this latest version of the hardware, and vice versa here. That is our release cadence example. And this is a really old one. I think I did change some of the dates to protect the guilty here, but it's just an example of kind of trying to dovetail our products with SUSE. All right, that was drivers, and I said we're going to do drivers, firmware, and agent software. Let's talk about firmware. I get it. Firmware is not a lot of fun, but it's something you really do need to keep updated. I mean, you upgrade your operating system constantly, right? You're always doing zypper upgrades. You really should be upgrading your firmware too, because it's software. Just because it's not part of the operating system doesn't make it any less important. So there's firmware embedded into everything. So what we do in HPE when we want to give out firmware, we RPM package it for a few different reasons. One, ultimately, RPMs have cryptographic signatures on their headers, and we can land the firmware payload on your file system, and it hasn't been compromised. It's all good, and there's usually some object code on there that'll actually flash the firmware. And in the service pack for ProLiant, which is what we're talking about here, there can be 100 plus firmware updates in each SPP. So do check out the service pack for ProLiant when it comes out, and see if you've got firmware that applies to your system. Remember I talked about the system update manager? It'll do all that work for you. And we've got some other cool tools, a more DevOps approach to managing firmware here as well. So this is the anatomy of a firmware RPM. I don't know if I can get out of my own way again here. So you install the RPM, like I said, and this is just me using CPIO to do a quick dump here. And when you install the RPM, it's going to land files in userlib x86-64 in the name of the firmware package. And then there's one command you got to remember there, and that's just the setup command. That's going to flash the firmware. That's the object code. You can see the firmware payloads here, this bin file. What is this for? This is for, again, for a QLogic NIC, it looks like. And the actual firmware RPMs have some intelligent information in them as well. They start with firmware. The second field is always going to be NIC if it's a NIC, or system. It's going to be QLogic as the vendor, and then maybe some, this is the NX version of the firmware. So anyways, this is kind of how firmware works from an RPM packaging perspective. Just run the setup command inside the RPM. Now that I told you all about how we package firmware in RPM packages, forget everything that I just said. We are transitioning to something called FWPKG. I think it makes more sense in the long run. So for a while, we're going to have both RPM package firmware and FWPKG package firmware. But in the long run, I think we're going to stick it out with FWPKG for a few different reasons. ILO can actually do the flashing with an FWPKG file. It's really, don't tell anyone, but it's just a zip file. And it has a signature on the front of it, and inside there's a binary payload for the firmware, and a little bit of metadata about it, a little bit of JSON inside there. That's what an FWPKG file. So it's not a new proprietary format. It really is just a zip file. But what's cool about it is ILO, our management processor, can actually do the flashing. So you can install firmware using any OS you want on your HPE ProLiant server, or no OS. That's what's cool. So you can get your hardware all flashed up before you even install an operating system using FWPKG firmware packages and ILO management processor. And of course, any Redfish aware code can flash firmware now, now that we are Redfish driven in our management processor. So you can use things like ILO REST to flash firmware, or use the ILO interface, web interface, whatever you like. It may be cut and pasted into Ansible. We really want to make these APIs open and accessible, because we know, the way you manage your hardware and your data center isn't always the same way other people do. So we want to make the APIs that we use for flashing firmware and managing hardware available to you, so you can use the same APIs. So you might be wondering, if we're going from RPM to FWPKG package files, how are we going to do this in online repositories? That came up. We can do that as well. Like right now, you would do like a zypper install. What was the name of that firmware package we had? Firmware Nick QLogic. And it would install the latest firmware using zypper. We do have a new thing. Actually, this is one of my pet projects. We have something called FWGit that allow you to search online firmware repositories. And this is GPL Python stuff. I wrote a lot of it. And it allow you to basically do FWGit search for a firmware, and then you download it, and then you can use the ILO REST command to actually flash the firmware using ILO, like I said. And ILO REST doesn't have to be running on the target system. It could be running on, a management server, an Ansible server, or something like that, and flash the firmware through the ILO. So now, example of FWGit here. Let's say you run FW. Let's say you got a DL380. I just say, hey, FWGit search DL380. And it came up with a couple of hits there. There's a Gen 10 and the Gen 9 variant. It always gives you the latest ones first. You notice these are always spaced, so you could use sed or awk or cut to programmatically get this information. It's kind of, think of it as a RESTful interface. There is a JSON index in our online firmware repository, so you could actually just read the JSON if you wanted to from a RESTful repository perspective. Then you can say FWGit download. Let's say you have the Gen 10. You got the U30 variant here. You can FWGit download. Let's see, the P89 FWPKG. It downloads the firmware, and then you use ILO REST with one command line option, and that's flash FWPKG and the name of FWPKG file, and it flashes the firmware. It's really that simple. So I think of this like as the DevOps oriented approach to flashing firmware. Now, don't get me wrong, you can use System Update Manager, and you can run that natively on your system, and it will look at all your firmware, look at all the new stuff, flash everything. You can do it in a more solution oriented approach. But if you really want to know how this works in the behind the scenes and get access to the APIs that we actually use, the things that System Update Manager actually uses, this is a great example of this. And so at the bottom here, I have this extreme command line tool chaining item here. ILO REST, you understand how this works. You can do everything up here that I'm doing in one command using ILO REST and some command line tool chaining. All right, I said we're talking about drivers, firmware, and agent software. All right, those are the big three. Agent software. So what is agent software? It's kind of like management software, I guess, would be to overgeneralize it. So anything in our service pack for ProLiant that isn't kernel module package or firmware, it's user space software, is what we're going to call agent software. And then we've got a bunch of that too to help you manage your system. So AMSD is right at the top of the list here. This is probably one of the more important ones. This helps report information about your operating system into the ILO management processor. So, because ILO doesn't know what your OS is doing. It doesn't know if a file system's full or not. It just knows if, the disk drives are operating. It talks to your hardware, not necessarily your OS. AMSD, I like the name of this one, Agentless Management Service Agent, right? Circular definition, I don't know what you'd call that. It helps bridge the gap between your operating system and ILO managing your hardware. So you get a complete picture of your system, not only hardware, but also your operating system stuff when you're using ILO to manage your system. So some older ones that you guys might be familiar with, system management homepage, that's going away. SNMP agents going away, health agents, those are going away. Those are dying with Gen 9 because all of that functionality is now in ILO with Gen 10 plus servers from HPE. We also have for managing like your RAIDs and seeing disk drive health, maybe you got a degraded RAID set or something. You can use SSA CLI for smart array stuff, Store CLI, kind of a working analog for Broadcom stuff. An HP on config to configure your ILO card. And there's some other stuff here. I'm not going to go into great detail here. But this is the agent software from the Service Pack for ProLiant that you might be interested in. And again, it's in the ISO media, and it's all on zypper or yast repositories as well at downloads.linux.hpe.com. This is some additional stuff. I'm not gonna read this slide to you. You guys can read this for the sake of time. It's sufficient to know that we've got some other good stuff out here for Linux. This isn't really agent software. This is maybe some more commercial software like Service Guard for Linux. It's a really cool way to do like continental clusters with SAN and failover. Check that one out. Like for Mellanox, if you want the OFED and VPI drivers from HPE, you can get them, from us, packaged by us. The drivers are signed by us, so it actually works for Secure Boot. ILO REST is a big one. This is a way to interact with the Redfish interface on HPE servers, so you don't have to use curl. It's kind of it makes ILO REST or Redfish a little easier. And Summons that I've mentioned a whole bunch of times. The Smart Update Manager, which is more solution or based a way to manage your hardware. Like I said, the one URL to take away from this presentation is going to be downloads.linux.hpe.com. I'll keep saying it, downloads.linux.hpe.com. Am I in the way here? Get out of my own way. Now, you can subscribe to one or more of these repositories. So most of the software I've talked about here is available using zypper. So you can just do, like I said, zypper install be2net kmp default, and it will install that driver on your particular system. Like I said before, you don't have to go out to websites to find drivers anymore. You can just subscribe to one of these repositories. You don't have to download an ISO image, right, and try and scrub that to get to the stuff you want. And of course, as a driver gets an update, you can just use like a zypper to find the latest updates as well. So you're not constantly searching. So you can allow zypper to find those updates as they become available also. So that is downloads.linux.hpe.com. I don't want to get into the details of these repositories. Remember I mentioned all of our firmware is in online repositories, so we call that the Firmware Pack for ProLiant. I created this. It's basically a collection of all firmware from HPE. You have there's actually a repository called Current. There's a repository called Next. These are firmware that are going to go into the next Service Pack for ProLiant. So subscribe to the FWPP for basically for a firmware stream from HPE to get the latest stuff. And also if you want to subscribe to a baseline, like the latest SPP version, you can do that. So we have the Firmware Pack for ProLiant has the same versioning scheme as the Service Pack for ProLiant. And of course, the SPP is a combined drivers and agent software and firmware here as well. So, this is just explaining some of the repositories in here to be aware of. ILO REST is a good one. You're going to want to subscribe to that as well if you manage your system through the ILO. Downloads.linux.hpe.com. The takeaway URL. I don't know. I'm in my own way here. Hopefully, I'm not covering up too much important data. All right, so this is the point where we normally answer questions. I don't know how we're going to do this when this goes live, but please ask some questions if possible. You have my email address. Krager@hpe.com. I'm going to be like that guy who put his own email address in the driver. I'll put my email address in my presentation. Hey, thanks a bunch for hanging out with me for the sponsor session. I really appreciate it. I hope SLES works great for you on HPE ProLiant servers. I know it's a lot of fun working with SUSE, and we're really proud to be sponsors here at SUSECON. So maybe we'll see you next year live. Again, my name's Craig, and hey, thanks for hanging out.